Okay, so we are reviewing the geometric formula for volume, for area, for perimeter, for some of the basic shapes, okay, and how to work expressions and how to work with geometry, and then we'll do calculus with it next week. All right, so we're going to start with an Algebra 1 problem, okay, in terms of the algebra. There's a little calculus you have to know, but we're going to start with this. All right, so this is an algebra problem. What values of the variables a and b would make for sure the function x cubed plus ax squared plus bx have a local minimum at -3 and a, local maximum at -3 and a local minimum at x equals 2. All right, so we have to understand, take what we know from calculus. What do you know happens at a maximum? A little horizontal tangent, a baby one, okay? So what does that mean in calculus, in calculus terms? The derivative has to be 0. Where does the derivative have to be 0?
-3 and 2.
It has to be at -3, at 0 at -3, and it has to be 0 at +2 also. Okay, so let's find the derivative. So our derivative f prime is, the derivative of x cubed, 3x squared. What about the derivative of ax squared? Okay, so it'll be 2ax. And the derivative of bx, knowing that b is a value, plus b. Okay, so what we know now is that if I plug -3 in for x into this derivative equation, what should be the result? Should be 0, because there should be a horizontal tangent at -3. So when I put -3 in for x, I still have an a there, and I still have a b there, but I know that it should turn out to be 0. So that gives me 0 equals 27 minus 6a plus b. You with me so far, algebraically? Also, when I plug in 2 for x, the result should also be 0, because I need to have a horizontal tangent there. So when I plug 2 in for x, that also should be equal to 0. So that gives me 0 equals 12 plus 4a plus b. Okay. The rest of this is algebra. Okay. These must both be true. It is true that -3 would produce a horizontal tangent. It's true that 2 would produce a horizontal tangent. So the 2 must be true at the same time. And your job is to find what values of b and a work to make these both true at the same time. So then this takes you back to some Algebra 1 stuff. Okay, from Algebra 1, you should know how to solve those equations simultaneously. All right, so any ideas? Put them next to each other so they equal each other, okay, because they're both equal to 0, okay? Okay. Okay, so that is called linear combination. That might work, okay? You should elimination, okay? Nathan, did you have an idea? No. Substitution. What would you do if you were substituting? Get b by itself and then substitute in the other equation. All right, Aubrey, did you have another one? Okay, so you have multiple options, right? So John says set them equal to each other. See what happens. Gretchen says do, and Rachel both say do elimination. See what happens. And then Nathan says get b alone. And see, all of those are valid, and all of those will get you to the right result. I love elimination, so that's what I'm going to do. Okay, because I notice that if I take the bottom equation and I multiply the whole thing by -1, it won't change the 0, it'll change the 12, it'll change the 4, and it'll change the b. So for me, I love that. If I can make that work, elimination is good for me because it takes the b's and it knocks them out of the problem. And then I will be left with 27 minus 12, which is 15, and negative 6a, negative 6a minus 4a, which is negative 10a, and that still has to be equal to the combination of 0. So I've eliminated b from the problem, and means I should be able to solve for a. So 10a equals 15. So a is 15 over 10, which is 3 over 2. Now that solved the answer for a. What also do I need to find? The answer for b. So I can go back to either of those two equations, doesn't matter which one, and I can find the value that I need for b. So I can take 0 equals 12 plus 4 times 3/2 plus b, and I should be able to figure out what b is for that. Because 12 times 4/2 is 6. So then b has to be negative 18. So my values that make this work are 3/2 for a and negative 18 for b. So most of this is algebra, just a little calculus at the beginning. Okay, are we ready to move on to geometry? Yes. Okay. Right. Okay, a cylindrical can. Okay, so this could be like a soup can, a Pringles can, anything that's cylindrical in shape, can hold 100 milliliters, which is the same as 1 liter. Find an expression for the height, then find an expression for the surface area. An expression means you're not going to find a numerical answer, you're going to find something that involves other variables. So we need to start with knowing how to do the volume of a cylinder. So the volume of anything, if it's right, if it's straight up and down, is based on the shape of the bottom multiplied by the sides, the height. Assuming that it's straight up and down. That doesn't apply to like cones because they come to a point. But this one. So what is the shape of the bottom? A circle. Okay, what is the formula for a circle, for the area of a circle?
2
Oh, that's the circumference of a circle. But thank you. Good geometry thing. Okay, pi r squared. So our volume is the shape of the base. Oh, well, let's say not the shape. Let's say the area of the base multiplied by the height. So that works for anything that's straight up and down. That works for boxes. That works for cylinders. Okay, it works for things that have rectangular bottoms but are straight up and down like a prism. So in this case, I know that my volume is 1,000. I know that the area of my base is pi r squared, and I know my height I'll just call h. So the directions first are find an expression for the height. That doesn't mean find the answer for the height, it just means find the expression, which is going to involve other variables and constants. In other words, just get height alone. Right? So to get height alone, I'll say the height is 1,000 over pi r squared. There's nothing else I can do with that. That's an expression for the height. The second part of this tells us to find an expression for the surface area. So the surface area are, the pieces. If you were to cut this thing out into pieces, what different shapes would you have? All right, well, there's multiple pieces that put this all together. All right, so the shape on the bottom is a circle. So is the shape on the top. What would the shape on the side be? Yeah, think about peeling a soup label, a label off the soup can. If you peel that off, it's just a rectangle, okay? And so this is the surface area is made up of a circle plus a rectangle. So the bottom circle is, of course, pi r squared. The other circle is also pi r squared. And then we need to figure out how do we do the area of this rectangle thing that was peeled off of the outer edge of this. Okay, well, how long is the base? The base is here from corner to corner, but the base had to wrap around the entire edge of that circular thing. So yeah, how do you go all the way around it? That's 2 pi r. So the base is 2 pi r. And then how tall is it? Oh, well, let's call it h first, okay? It's h. And so my surface area is pi r squared plus another pi r squared plus 2 pi r h. But what I'm going to do now is replace that h with the expression that I'd found from h from the volume. So to simplify. So I can put the two circles together. So it'll be 2 pi r squared. And then I can replace h. So 2 pi r. And then I can replace that with 1,000 over pi r squared. And that will simplify as well. What can I reduce there? The pi, okay, can reduce pi. Anything else? And 1r with one of the other r's. So I end up with 2 pi r squared plus 2,000 over r. And that is an expression for the surface area. Okay, it's not the answer to the surface area, it's an expression. This is the kind of geometry that you'll need to do next week. We'll do calculus after that, but you got to do the geometry at the beginning. Okay, any questions about that one so far? All right, so let's try another one. Here is a method of forming a box out of a single sheet of paper. The box doesn't have a lid, the top of it is open, but it takes scissors and some folding. So if you start by a 16 by 19 piece of paper and you take your scissors and you cut out the corners and then you fold it along the edges of what's left, that will form a box. So what we want to know is to figure out the base of this box and what its dimensions are. So let's look at the long edge, the longest base. It started out as 19 from corner to corner, but I made 2 cuts there. So how long is that length now? Say it again. 19 minus 2h, h from one corner and h from the other. And so this edge is, oops, not 16, is 19 minus 2h, because now this is gone and so is this. I've cut it away. All right, the shorter side of the base is a similar approach. It used to be 16, but I cut 2 corners away from that. And so now that is 16 minus 2h. And the one opposite is still 19 minus 2h. And this one over here is 16 minus 2h. And all the corners are cut away. And then we start to fold up the sides. And that's where you get the shape that's left here. All right, so you can tell I've labeled on there the short side of 16 minus 2h. You can add the label onto the long side of 19 minus 2h. And then where the edges meet each other becomes the height. And that height is h because it matches the size of the squares that were cut out. So once you have all the sides, you have the length, you have the width or the depth, and the height. You have that all set up. Then you can write an expression for the volume. So we know that the width of this is 16 minus 2h. We know that the length of this is 19 minus 2h. And we know that the height is regular h. So then write an expression for the volume. So V would be the expression width times length times height. So 16 minus 2h times 19 minus 2h times h. What other algebra could you do to simplify that? You'd want to FOIL. You'd want to take your 16 minus 2h and 19 minus 2h, FOIL that out, take that and multiply it by h. Would you please finish that part for homework? Okay, finishing the FOIL part. Then I can start the next one with you. Okay, now we're going to go to perimeter. So draw a rectangle whose corners fit. To be inscribed under means the corners fit under the parabola. Let's figure out where these corners are. Okay, now I'm not saying that that corner is exactly 1 point something. We don't know where that is yet. This is just a drawing. So I'm going to call that corner x, comma, and what would the y value be? I don't know exactly how far it is, but what would the y value be? 0. Okay, what about the corner on the opposite side? Okay, if 1 on the right in quadrant 1 is x0, what would the one on the other side be? Have to be negative x0. Okay, and then so what would the base from corner to corner be of this rectangle? X that way and negative x that way. How much total? It's 2x, right? All right, then we've got the top corners. What is that one I just drew up in quadrant 1? What does it have the same as the corner below it? Okay, it's also x, right? And then we don't know how tall that is, but we know that it is y, tall. Okay, on the final corner, we know that that's negative x, so as it shares that with the corner below it, but what does it share with the corner across from it? Also y. So then how tall is the height? Okay, the height is y, but what was y equal to? Okay, y is equal to 8 minus x squared. So the height is y, but y is equal to 8 minus x squared, so we can say that that is our height. All right, so using the x variable, write expressions for the base, height, and perimeter. So we know that the base is 2x. We know that the height is 8 minus 2x. So we should be able to write a perimeter from what you remember about geometry. Oh, sorry, x squared, not 2x. Okay, so what do you remember about perimeter from geometry class? Okay, 2 bases and 2 heights all the way around. So our perimeter would be 2 of the 2x's plus 2 of the 8 minus x squared. And I'd like you to finish that for homework just to clean that up. Okay, we have one more. Okay, here is another rectangle inscribed whose corners fit under the sine curve, but it's a little different about where the positions are because of where 0 is. So let's look back at the previous one. Where was the origin? In the middle. That gave us symmetry. This one, the origin is over here. It doesn't give us symmetry anymore, but it doesn't mean we can't do it. This corner right here is going to be our x0 corner. We had an x0 last time. It's the corner that is closest to the origin on the right. So look at the last one we did. Okay, see where the origin was? And then to the right, it's the closest corner. That's x0. So the same thing is true here. There's the origin, and I go to the right, and that's the corner. That is x0. So let's go straight up. Okay, what will that share in common with the corner it's directly above? Okay, that will be x, and then y will be its height. Now here is what usually is the hardest part to come up with. What is this second corner sitting here on the base. Okay, that's hard to figure out. Kind of like the cutting that we did, okay? It's not x plus 2. Okay, so tell me this. Do you know what this is on the edge of the window? It's pi, because the window tells us it's pi. So if the whole thing from origin to the whole window is pi, and if I were taking my scissors and if I were cutting all of this off, how much would I be cutting off? X. And on this side, if I were to be cutting all of that off, how much would I be cutting off? X. So how much is left in the middle? Pi minus 2x. That's usually the hardest part, is to figure that out. Okay. All right, you should be able to figure out the height, and then you're going to finish this one by writing an expression for the base, the height, and the area.